Arduino for Beginners, Episode 15, the Hall Effect Sensor. Now there's lots of different things you can do with the Hall Effect Sensor, but in this tutorial we're going to do just a basic. We're going to use it to turn an LED off and on. Then in the next tutorial we're going to look at using interrupts and make a counter to count how many times it's been magnetic field's been detected. And then further on down, once I get the sketch finished, I'm still working on it. I'm working on a tachometer. That'll be a few episodes down, but this one and the next one we're going to deal with the Hall Effect Sensor here. Now I'm using a 3144, which is very common. And these can be found on eBay extremely cheap. You can get like 10 of them for $1. That's shipping included. And this is the pinout for hooking up. Now you can use other Hall Effect sensors, and commonly they're either all the way on or all the way off. But then they have linear ones and then latching. Now you could use a linear with this. It'll be just slightly different how the sketch would work, but this is just a lot of people call them the simple. It's either all the way on or all the way off. So if you've got a Hall Effect sensor of any type that's just all the way on or all the way off, it's going to work for this. Like I said, this is a 3144, which is really common, and I'll show you it working here. Once the magnetic field comes close enough, it turns that on. Now I'm using neodymium magnets, the really strong ones. If you were using a cheaper magnet, you'd have to get real close. But the pinout of it, here's a picture right here too. Your pin number 1 is your voltage in. Now the 3144 works on anything, I think it was 4.5 volts to, it was 26 or 28, somewhere right in there, which makes it perfect to use with the Arduino. Then your middle pin is the ground, and pin number 3 here, that's your output. Now a Hall Effect sensor works almost like an NPN transistor. The difference is, instead of, for the base, it uses a magnetic field to activate it, and instead of being able to have a varying current, it's all the way on or it's all the way off. But it works real similar to a NPN transistor. Otherwise, that's all you have to do to hook it up. Now I have it hooked up to pin number 2 because we are going to be using the same setup in the next episode. We're going to take a look at making a counter and using interrupts, and your interrupts on the Uno are on digital pin 2 and 3. So I set it up this way so we don't have to change anything to go to the next episode. And then the LED, you can use the onboard LED that's on 13. Otherwise, you can just stick an LED in like this, and it has the resistors already built into the board on pin 13, so you don't have to add anything extra. And then you just got your power and ground running the 5 volt and ground on the Arduino. All right, I think we can go over and take a look at the sketch. Sketch is pretty simple. This is going to be a pretty short episode. But then we'll get over to the next one after we finish this one up. And that we're going to have a little more fun with. We're going to deal with some interrupts. And then after that, I think we might do start playing with LCD screens. But all right, let's go over to the computer and I'll show you the sketch on how this works. All right, I got the Arduino IDE opened up here. Before I forget, I forgot one thing I remembered once I got over to the computer here. The Hall Effect sensor, this particular type, it's polarity determined. I do believe this needs the south pole of the magnet to work. I don't think it's the north. But you have others like the latchings and the linear, which uses both sides for either making let more current flow or less, and the latching, one side latches it on, the other side turns it off. But yeah, it's pole dependent, so only one side of the magnet will activate, turn the the Hall effect on, or close it, I mean, so that your current can flow through. All right, well, let's get down to the sketch here. Super simple sketch. This is all there is to it. I'm going to run through it super quick so we can get over to the next episode. So we're just defining the Hall effect sensor is on pin 2. We're defining the LEDs on pin 13. We're going through our setup, and we're activating the input pull-ups. Because, like I said, this works like an NPN transistor, so we want to have the pin high that the Hall effect sensor's on, and when the Hall effect sensor is activated, it will bring it down the ground, which will tell it down here in the if statement it's low. Then our pin mode for the LED, of course, is an output. Like I just said, we're going to do an if statement here in the loop. If we're going to digital read the Hall effect sensor, which is on pin 2, if it's low, which means a magnetic field is in proximity to it, it's going to digitally write the LED high. If there's not, we're going to do an else statement and just write it low. That way, when the magnetic field is taken away, it turns the LED off. And then I'm just simply putting a delay of 100 in there just for stability. You could run this at like 10 if you wanted. I wouldn't go much over 100. Otherwise, it'll just be a little slow when you pull the magnetic field away. All right, that's all there is to this. I just wanted to get this video up quick to show you how to hook this up and let you play with it, for a little bit. Because in the next couple episodes, we are going to be looking at doing some other things, and we're going to be building off using the Hall effect sensor. So like I said, the next episode, episode 16, we are going to take a look at making a counter by using interrupts. And that's something new we haven't covered yet. So we'll be using the interrupts in the Arduino to make a counter, and I'll explain that more when we get over there. So, all right, well, thanks for joining us here today. Hope you have a great day. I hope to see you here again in the next episode.